So recall in last class we were solving a problem based on the free vibration of multi-degree of freedom system. A quick review through what we have done till now. So you have two masses M1 and M2 जिनके values यहाँ पे दिए हैं. Then you have two temper elements C1 and C2 जिनके values दिए हैं. You have two stiffener elements K1 and K2 जिनके values दिए हैं. Are you with me? 2 degrees of freedom we are monitoring. One is u1 of t, that is x directional deformation of mass m1 at time t, and x directional deformation of mass m2 at t is u2 of t. ये 2 degrees of freedom हम monitor कर रहे हैं. Are you with me?
Yes, sir.
And f2 of t is given as 0, f1 of t is given as 0. However, this system is initially disturbed. इसमें u2 of 0 is given as 100 mm. That means the second mass has been pulled towards right of its mean position by 100 mm. And u1 of 0, however, is at its mean position itself. And u2 dot of 0 is 0 and u1 dot of 0 is 0. That means the system starts from rest. ये conditions हमने दिए थे. Are you with me?
Yes, sir.
Then we wrote down the matrix form of equation of motion, and we saw that these equations are coupled. So what is the next thing that we did? In order to decouple this system, we found out transformation matrix, something called as phi. How did we find out phi? So phi is phi find out करने के लिए steps क्या है? So first of all, we calculated matrix M inverse K. Then we found out its eigenvalues and eigenvectors. These eigenvalues were ordered in an ascending fashion, and corresponding eigenvectors जब हम एक के सामने एक रख देते हैं तो जो मैट्रिक्स फॉर्म होता है उसको हम phi मैट्रिक्स बोलते हैं. Are you with me?
Yes, sir.
For example, here we had two eigenvalues 30, 40 and 3.33. तो ये रिवर्स फैशन में आए थे, उसको हमने अरेंज किया असेंडिंग ऑर्डर में 3.33 and then 40. Eigenvector corresponding to the lowest eigenvalue is kept as the first column of phi matrix. Eigenvector corresponding to the second eigenvalue was kept as the second column of phi matrix. Happy?
Yes, sir.
And then we claimed that if this is going to be the phi matrix, phi transpose k phi is going to be diagonal. Are you with me?
Yes, sir.
And I proved that claim. Also, we discussed something about the mass proportional, stiffness proportional, and mass and stiffness proportional damping. So as long as damping is mass and stiffness proportional, that same phi matrix is also going to diagonalize C. Happy?
Yes, sir.
So then we applied the transformation. What is the transformation that we did apply? We said that u is equal to phi z. Are you with me?
Yes, sir.
Then z is the generalized displacement, u is the parent displacement. So u equal to phi z. We also saw the sizes of all matrices, and then we have back substituted this in the governing differential equation, and we obtained the equation in generalized coordinate system. Are you with me?
Yes, sir.
And in generalized coordinate system, as we have phi transpose m phi, phi transpose c phi, and phi transpose k phi, all these matrices are diagonalized. Are you with me?
Yes, sir.
तो यहाँ तक हमने किया था, and then we also transformed the initial conditions by applying transformation u equal to phi z और z is equal to phi inverse of u. ये अप्लाई करके हमने इनिशियल कंडीशंस को भी जनरलाइज कोऑर्डिनेट सिस्टम में ट्रांसलेट कर लिया था. Do you agree with me?
Yes, sir.
So now we have initial, these are the initial conditions, 4 initial conditions in generalized coordinate system, and we have two differential equations. So we have expanded the first row, and we got this first differential equation with the first set of initial conditions. Are you with me?
Yes, sir.
Then we expanded second row, we got the second set of differential equation with the second set of boundary conditions. And then looking at its similarity with the equation of motion for single degree of freedom system, I did calculate something called as omega 1 natural frequency of first corresponding to first equation. It turned out to be 1.825 radian per second, और उसका जो square है that square turned out to be first eigenvalue. Do you agree with me?
Yes, sir.
देन सेकंड इक्वेशन में हमने क्या किया, सेकंड इक्वेशन में भी हमने we calculated the natural frequency corresponding to second equation. I called it as omega 2. It turned out to be 6.325 radian per second, and the square of that was equal to the second eigenvalue. Do you agree with me?
Yes, sir.
Now just have a look at diagonalized matrices. If you look at the diagonalized M matrix and then diagonalize K matrix. Okay, we will talk about that little later. Please pardon me. Now let us look at the damping coefficients. Means what is the value of eta in first case? Can I compute value of damping coefficient eta? Follow eta 1 for the first equation. ये कैसे हम calculate करते हैं? It is damping ratio, not coefficient. It is damping ratio, and it is damping coefficient C1 divided by C star. That is critical damping for this system of equations. So I am going to call it as C1 star. Do you agree with me?
Yes, sir.
तो इस case में can you tell me what is the value of C1? The value of C1 is 42.
44.
44, I'm sorry. And what is the value of C star? The value of C star here must be equal to 2m1 omega 1. Do you agree with me?
Yes, sir.
So what is m1? 1320.
1320.
I will substitute that. So 44 divided by 2 into 1340. Are you with me? Into omega 1. What is the value of omega 1? Tell me. Omega 1 is 1.825.
1320. No?
Yeah, 1320. So can you do this calculation and tell me the value of eta 1? It is 44 divided by 1320 divided by 1.825 divided by 2.
44. Second.
Yes. Has it turned out to be 0.00913? Is that right? Just cross verify and let me know. Yes, I need you to cross verify. Others also
Right, right.
can.
Right, sir. 0. Point.
Okay. Now let us try to find out eta 2. So in this equation, eta 2 will be equal to C2 divided by C2 star, where C2 is the damping ratio for this equation. What is the damping ratio for this equation? 440. And what is C2 star? It is 2m omega. So what is the value of m here? 1100. And what is the value of omega here? Omega 2 is कितना था? 6.325. 6.325. So can you tell me how much is this? So it is going to be 440 divided by 2 divided by 1100 divided by 6.325.
0.031.
0.0316.
031. 16.
You agree with me? And so can I call this as 0.913%? And can I call this as 3.16%? Dekho, I have already told you that steel structures have a damping of around 2% and RCC structures have damping of around 5%. So these values are okay. They seem to be little off. It's all right. As we are solving this as a theoretical problem, it should be fine. Are you with me?
Yes, sir.
Okay. So now this is eta 1 and eta 2. Now we are going to look at the governing differential equations. Are you with me?
Yes, sir.
Yes, this C1 is there, this C2 is there, and we are trying to compute from this in parent coordinate system what is the value of eta 1. I will call it as eta 1 star. तो यहाँ पे वैल्यू क्या है जरा बताओ. 100 divided by 2 into m omega. So m is 1000. Are you with me?
Yes, sir.
And omega is root k by m. So this is 10,000 divided by 1000. Can you tell me how much is this value?
0.015.
0.158.
0.158.
So you have to understand that this way whatever value of eta we get is not same as the value of eta that we get in generalized coordinate system. Are you with me?
Yes, sir.
This value is of very little use to us because we are going to solve the system in generalized coordinate system. Happy?
Yes, sir.
So having said that, let us move ahead. Now we will solve these two equations. Can you solve these two equations? Are we equipped with the solution for a single degree of freedom system exhibiting vibration when it is initially disturbed with initial velocity 0 but initial displacement non-zero? इसका solution हमारे पास है. Yes, we have the solution for it. So I will have to look at few initial lectures. So let me look at that 1 minute. Does anyone know in which lecture it was taught? Yeah. So probably it was in third lecture. Let me find out the solution. And the value of eta is less than 1. So we are dealing with underdamped system. Are you with me?
Yes, sir.
Okay. So yeah, I think I got the solution. 1 minute. Okay, let us not rely on that solution. We can derive it ourselves here. What is the typical solution for this? Can you tell me? It is going to look something like this. E raised to minus eta omega t. Do you agree with me? Into
Yes,
a cos omega dt plus b
plus
sin
B sine
omega dt.
omega dt.
Do you agree with me?
Yes, sir.
How the solution is going to look like. अब हम क्या करेंगे? This is the general solution u of t. Now I will call or I will call it now as z of t. Are you with me?
Yes, sir.
And now we are going to obtain z1 of t and z2 of t. Happy? So z1 of t and z2 of t. So quickly मुझे terms calculate करके बताओ. What is the value of z eta 1 in the first case? That we have already calculated. That value is 0.00913. Happy?
Yes, sir.
What is the value of eta 2 here? That value is 3.16%. That is 0.00316. I am sorry,
One.
0.0316. Right?
Yes, sir.
Then tell me the value of omega 1 here. That also we have obtained. That is how much? 1.825. 1.825 radian per second. Happy?
Yes, sir.
What is the value of omega 2 here? So we call these as natural frequencies. First natural frequency and second natural frequency. If you look at the books, they will tell you it is first mode natural frequency and it is second mode natural frequency. I am intentionally avoiding the word mode because we have not yet discussed it. So once we write down the solution, then I will discuss about what is something called as mode shape. Are you with me?
Yes, sir.
So अभी तो इसको हम फर्स्ट नेचुरल फ्रीक्वेंसी बोलेंगे और सेकंड नेचुरल फ्रीक्वेंसी. So what is the second natural frequency of this system? Omega 2 is equal to 6.325. Are you with me? You have to also understand that these frequencies are in radian per second and these frequencies are not in hertz. Are you with me?
Yes, sir.
Okay, now can you tell me what will be the value of omega d1? So omega d1 here will be equal to omega, that is 1.825 square root of 1 minus eta square, that is 0.00913 square. Happy? Calculate this value. Tell me how much it is. What is omega d1? Yes.
1.824.
So it is, this has marginally changed. So let me write it as 1.824 radian per
Radian
second.
per
It is
second.
important to emphasize the unit. This is not in hertz. It is in radian per second. How do you get the first natural frequency in hertz? You have to multiply this by 2 pi so that you get the first natural frequency in hertz. Now what is value of omega d2? It is 6.325 square root of 1 minus eta square 0.0316 square. Yeah, tell me.
6.321.
6.321
321
radian
per
per
second.
second. So, are we equipped with everything that is required here? Yes, but let us first apply the boundary condition. So, if I apply boundary condition here, so can you tell me what will be z dot of t quickly? Z dot of t कैसे आएगा बोलो? तो पहले तो I will keep e raised to minus eta omega t as it is, and I will take derivative of some the derivative of that bracket. So e raised to minus eta omega t into bracket a omega d sine of and minus sign minus a omega d sine of omega d t. Happy?
Yes, sir.
Plus b omega d cos of omega d
Omega.
t, right? Plus up e raised to minus eta omega t का derivative, that turns out to be minus eta omega e raised to minus eta omega t into a cos omega dt plus b sin omega dt. Happy?
Yes, sir.
Okay. Having said that, now let us apply boundary conditions here. So if I apply boundary conditions, what do I get? 1 minute. Yes. If I apply boundary conditions here, what is the first boundary conditions? For boundary condition, z of 0 is z0. Are you with me?
Yes, sir.
This is equal to, what is z of 0? If I substitute t equal to 0 here, this term becomes 1. This term becomes 1, so therefore it a remains. And b vanishes because sine omega t will be 0. Do you agree with me?
Yes, sir.
Yeah. So what is the value of a? A is equal to z0. Now let us apply second boundary condition. Z dot of 0 is z0 dot. Are you with me?
Yes, sir.
This must be equal to. Now I have to substitute time t equal to 0 in this expression. So this becomes 1. This vanishes. This remains b omega d. B omega d. Happy?
Yes, sir.
Then minus eta omega remains. This term becomes 1. Uh, this term vanishes and you have here a. So minus eta omega a. Happy?
Yes, sir.
So what is the value of a? Tell me. So a will be equal to beta omega d minus
Minus.
z0 dot this entire thing divided by eta omega. Happy?
Yes, sir.
Great. So now let us apply boundary conditions for the first case. So if I apply boundary conditions for the first case, a1 here becomes equal to Z01 or Z10. That's how we have called it. Z10. What is Z10? 0 point this number. Are you with me?
Yes, sir.
So I have got the value of first constant A1. Now let me compute value of B1. So what is value of B1? B1 is equal to no, यहाँ कुछ गड़बड़ की क्या हमने? It should be B, not A. Am I right? देखो, when you substitute T equal to 0, कहाँ गड़बड़ की है हमने, बताओ?
Yes.
Okay. So we have to compute B, right? Eta omega A. This was correct. This was correct. What is the value of A? A we have already computed. Value of A is Z0, if I'm right. Yes. So I have to substitute A equal to Z0 here. Are you with me? And then B becomes equal to Z0 dot eta omega Z0. This entire thing divided by omega D. Is that right?
Yes, sir.
Okay. So Shubham, so we will change this. What is the value of B1? B1 is equal to Z10 dot Z10 dot and then plus eta omega Z0. So plus eta 1 omega 1 Z10. This divided by omega D1. Do you agree with me?
Yes, sir.
Now, do we have all the values? Yes, we have all the values. What is Z10 dot? So we will have a look at this condition. Z10 dot is 0. So therefore the first term becomes 0 plus eta 1. What is the value of eta 1? 0.00913. Happy, multiplied by omega 1. What is the value of omega 1? 1.825. What is the value of Z10? This number. Are you with me? This entire thing needs to be divided by omega d1. What is the value of omega d1? It is 1.824. So can you tell me the value of beta b1? So it is 0.00913 into 1.825 multiplied by
Eight
0.00909.
8.304.
No. How can it be divided by 1.824? No. कुछ तो गड़बड़ की है, फिर से करो. Zero. It should be 0.000830 if I'm right. Can you cross verify? See, it's very easy. 1.825 upon 1.824 is almost 1. So it is multiplication of 0.009 into 0.09. So 9 nines are 81. And you are going to have 1, 2, 3, 4, 5 decimals before 81. So when 80, including 81. So 1, 2, 3, 4, 5. So this value seems correct. 0.00083. Are you with me?
Yes, sir.
Shubham. Okay. So this is value of B1. So can we now write down the solution? Yes. Nothing is going to stop you from writing the solution now. What is the solution? Z1 of t is equal to e raised to minus eta omega t. So what is eta minus eta omega? E raised to कहाँ है वो eta? हाँ 0 point. So minus 0.00913. minus eta omega. This omega is now not omega d, it is omega 1, that is 1.825. 1.825 e raised to minus eta omega into t. Are you with me? This multiplied by a cos omega dt. So what is the value of a? Are we making some error? Just a minute. Let me go back to lecture number 3. Just a second. Omega d is missing. No, sorry. That's correct, right? u0 cos omega dt, u0 dot plus eta omega u0 sin omega dt. Yes, that's right. Okay, so we are on the right track. Just give me a second. So into a cos omega, a1 cos omega dt. So a1 is this value, 0 point whatever it is, cos of omega d1. So what is the omega d1 value? 1.824. Are you with me?
Yes, sir.
Plus p, that is this 0.00083 sine 1.824t. Happy?
Yes, sir.
So let us simplify it further. So I get z1 of t as, can you do this multiplication? Tell me the value. 0.00913 into 1.825. So it turns out to be 0.017. Is that right? Shubham?
0.016. Right, sir.
0.166. So it is 0 minus 0.017. Happy?
Yes, sir.
Into 0.090909 into cos of 1.824t plus 0.00823 sine of 0008. 0.008 sine of 1.8242 t. Are you with me?
Yes, sir.
This is the solution of first equation. Can we quickly write down the solution of second equation? Chalo. Let us do that. Second equation में we need to calculate a2. That value a2 is going to be equal to z20. What is the value of z20? Did we find out that? Yes. It is minus 0.060984. Are you with me? Shubham?
Yes, sir. Yes, sir.
Okay. So therefore this must be equal to, these numbers can make you mad, but we are simply writing down whatever we have derived earlier. It's only that you have to keep the patience. Nothing new is being taught here. ये तो हम वैसे ही कर रहे हैं. Are you with me?
Yes, sir.
Okay. So A2 मिल गया. Now what is the value of B2? So B2 is equal to Z20 dot plus eta 2 omega 2 Z20 this divided by omega d2. So quickly, what is the value of Z2 0 dot? 0. So this value turns out to be 0 plus what is the value of eta 2? Eta 2 is 0.0316. Happy?
Yes, sir.
Multiplied by what is the value of omega 2? 6.325. What is the value of Z20? It is minus 0.060984 divided by omega d2. What is the value of omega d2? It is 6.321. So can you tell me the value of b2? चलो बताओ. 0.0316 into 6.325 into 0.060984 divided by 6.321. So I got it as
Minus
0.0019 minus
minus 0.0.
0019. Is that right?
Right.
Okay, great. So A1 is there, now A2 is there. So what are we going to do? We are going to now write down Z2 of t. So what is Z2 of t? E raised to minus eta 2 omega 2. So what is eta 2? 0.0316. What is omega 2? It is 6.325.
3 to 1.
This multiplied by A2, that is minus 0.060984 cos of omega d, that is 6.321 t. Happy? Plus b, that is minus 0.0019 sine 6.321 t. Happy? This is the expression. So now we are going to write down Z2 of t just below this by further simplifying it. So it is e raised to minus. So can you tell me what is this product? 0.0316 multiplied by 6.235. 0.197. Do you agree with me?
Yes, sir.
Is it correct?
Yes, sir.
No. 325. 0.199 if I am correct. Right? 0.199 t into bracket. चल क्या लिखूं? Minus
J-
0.060984 cos of 6.321 t plus minus 0.0019 sine of 6.321 t. Happy?
Yes, sir.
Now, one thing we are going to observe and then we are going to move ahead. What can you say about decaying of Z1 of t and Z2 of t? Which one decays fast? Which one decays faster? देखो जो ब्रैकेट में वैल्यू है उसकी वैल्यू तो प्लस माइनस सम वैल्यू के बीच में फ्लक्चुएट होने वाली. डू यू एग्री विद मी? तो ब्रैकेट भूल जाओ, लेकिन ये बाहर जो टर्म बैठा है दैट इज माइनस 0.017 एंड e रेज टू माइनस 0.199 विच वन ऑफ दीज फंक्शंस डीके फास्ट? डीके फास्टर? डीके फास्टर? बोलो.
Sir, Z2.
Yes, so therefore you have to understand, as we go to the higher modes, inherently these modes do respond, their responses do decay down faster. Are you with me?
Yes, sir.
So to demonstrate this, what I'm going to do is I'm going to plot a graph. Just a second. This is digress. We have not yet solved the problem. This is not a part of solution, but I want you to have a look at these two functions. Are you with me?
Yes, sir.
So let us create a new sheet here. We will call it as dk, and let me have values of t here. I hope you are able to see my screen. Are you?
Yes, sir. Yes, sir.
So 0, then 0.1. So in the increments of 0.1, let me take it to 17 seconds. And now I am going to plot exponential. This is equal to exponential minus eta, the first function, that is minus 0.017 t, minus 0.017 into t. T is nothing but column A. Are you with me?
Yes, sir.
And just next to that, I am going to plot exponential minus 0.199 into t. Are you with me?
Yes, sir.
Let us plot this on same graph. एक मिनट, insert scatter. अरे ऐसे क्यों हो रहा है अचानक? So t, चलो I will call it as Z1. I will call it as Z2. Z2. Hopefully now the things will work out. Yeah. So this is how it reduces. Are you with me? So a value 1 tha, and it has reached only to 0.7 in 17 seconds. Are you with me?
Yes, sir.
Now let us plot this one. So see, in 17 seconds, it has almost reached to 0. Are you with me?
Yes, sir.
So we have to understand that the effect of eta is significant, and therefore as we go for higher and higher frequency, तो decay fast होने वाला है. Are you with me?
Yes, sir.
So as a thumb rule, higher natural frequencies के corresponding single degree of freedom systems will decay faster. Are you with me?
Yes, sir.
So we have made this conclusion, and let us go ahead now. Now, are you interested in Z1 of t and Z2 of t, or are you interested in U1 of t and U2 of t? Tell me. Z1 of t and
Sir.
Z2 of t are the deformations in transformed coordinate system. उसका मैं क्या करूँ? I want the response to be in original coordinate system. That is U1 of t and U2 of t. Do you agree with me?
Yes, sir.
So how do I get response in original coordinate system? That's very easy. You already have the transformation. What is the transformation? U of t, this is a matrix. Its size is 2 cross 1. What are the elements? U1 of t and U2 of t. Are you with me?
Yes, sir.
These are the elements of this matrix. This is equal to phi, which is a transformation matrix. This is the transformation that we applied, and that is 2 cross 2 matrix. Are you with me?
Yes, sir.
This multiplied by z of t. This is also a 2 cross 1 matrix. And it looks like z1 of t and z2 of t. Happy?
Yes, sir.
This phi matrix is not a function of time. It is not a function of time. However, this u of t and z of t, these are functions of time. Do you agree with me?
Yes, sir.
चलो अब आई एम गोइंग टू राइट डाउन दिस इक्वेशन इन लॉन्ग हैंड. तो कैसे लिखने वाला हूँ? u1 of t, u2 of t. I will omit the argument t because you know that these two are functions of time. This is equal to first row first column element of phi matrix, first row second column element of phi matrix, second row first column element of phi matrix, and second row second column element of phi matrix into z1 and z2. Agreed?
Yes, sir.
Are you with me? Yeah. Now
Yes,
expand
sir.
these rows. So how do I write u1 of t? u1 of t now will be equal to phi 11 z1 of t. Are you with me?
Yes, sir.
Plus phi 12 z2 of t. Agreed?
Yes, sir.
What is u2 of t? Tell me. Phi
521
21 z2 of
Z
t,
of T.
z1 of t,
Z1 of T.
z1 of t plus phi 22.
522 Z2 of T.
Now we are going to make few observations here. In first problem solve करना ये तो चीज है ही, but we have to also understand. Now look at u1 of t. u1 of t is the response of first mass in the original coordinate system is dependent upon the response of both the masses in generalized coordinate system. Do you agree with me? z1 of t और z2 of t दोनों के ऊपर dependent है. Happy?
Yes, sir.
Similarly, u2 of t, which is the response of second mass in parent coordinate system, is dependent on response of both the masses in generalized coordinate system. z1 of t और z2 of t दोनों पे dependent है. Are you with me?
Yes, sir.
Okay. Now, can you tell me what is phi 11 and phi 21? ये दोनों क्या है? जरा बता सकते हो? This is the eigenvector corresponding to the lowest eigenvalue. Do you agree with me? So eigenvalue को अगर मैं lambda 1 बोल दूं जो कि है ओमेगा 1 का स्क्वायर. Are you with me?
Yes, sir.
तो उसके corresponding जो eigenvector है, that eigenvector is phi 11 and phi 21. Do you agree with me?
Yes, sir.
Then phi 12 and phi 22. These are the eigenvectors corresponding to lambda 2, which is omega 2 square. Do you agree with me?
Yes, sir.
हाँ. अब जरा एक hypothetical situation ले लेते हैं जिसमें z1 and z2 both are 1. Hypothetical situation. Just give me a second. Hello.
Yes, sir. Yes.
मॅडम लेक्चर चालू आहे. हा. ओके. अहो लेक्चर चालू आहे, पाऊणपर्यंत लेक्चर आहे. दुपारी जाऊ. So this is eigenvector corresponding to lambda 1. This is eigenvector corresponding to lambda 2. And now assume by some coincidence, suppose z1 and z2 both are 1. Are you with me?
Yes, sir.
So if z1 and z2, this all digress is going on. This is digress. z1 is 1 and z2 is also 1. Then what will be the value of u1 and u2? If I were to answer that question. Or no, I made a mistake. I'm sorry. Not Z1 and Z2 are 1. Imagine that phi 12 and phi 22 both are 0 for some reason. Phi 11 and phi 22 both are 0. So can you tell me what will be the u1 of t? It will be phi 11 z1. Happy?
Yes, sir.
And what will be u2 of t? Yes, tell me. It will be
Five,
phi
five,
21
two, one.
into z2.
Z.
Are you with me?
Yes, sir.
What is u1? u1 is the displacement of first degree of freedom here, and u2 is the displacement of second degree of freedom. Are you with me?
Yes, sir.
So in this particular situation, the response u1 and u2 will be dependent only on phi 11 and phi 21. Do you agree with me?
Yes, sir.
Only eigenvector of first eigenvalue. So अब जरा देखो, by definition we call this first eigenvector as first mode shape. Are you with me? क्या बोलेंगे हम इसको? First mode shape. Let me write it here. First mode shape. What is the meaning of this first mode shape? So whenever the first degree of freedom m1 displaces by amount phi 11, the second degree of freedom will displace by amount phi 21. Are you with me?
Yes, sir.
And any multiples of this, any scalar multiples of this, not key, we will call it as alpha. Any scalar multiple of this will also qualify as the first mode shape. So it is qualitative representation of the first eigenvector. Do you agree with me?
Yes, sir.
क्वालिटेटिव क्यों? क्योंकि अल्फा से मल्टीप्लाई किया है, क्वांटिटेटिव नहीं बता रहा. अल्फा कैन बी एनीथिंग एक्सेप्ट जीरो and infinity. It can be 0, 0.1, 0.21, 10,000, 10 lakh, 10 million, whatever it is. Are you with me?
Yes, sir.
Okay. Now, similarly, phi 12 and phi 22 is called, this second eigenvector is called as second mode shape. Do you agree with me?
Yes, sir.
Now, u1 of t in general receives its components from first mode shape and second mode shape. देखो, phi 11 is from first mode shape and phi 12 is from the second mode shape. Do you agree with me?
Yes, sir.
Okay. Now let us try to similarly u2 of t receives its response from both the mode shapes phi 21 and phi 22. Happy?
Yes, sir.
Okay. Now let us try to write down these values of phi. So have we calculated phi? Yes. Where is the phi? This one. Are you with me?
Yes, sir.
So let me write down that value here. So what will be the response of the system? Phi 11, that is 0.6 multiplied by Z1 of t plus 0.89443 into Z2 of t. Are you with me?
Yes, sir.
Then phi 21, that is 0.8 multiplied by minus 0.44721 minus 0.44721. Are you with me? Times Z2 of t. Do you agree with me?
Yes, sir.
Now, you can see that this Z2 of t is going to approach 0 at a faster rate than Z1 of t. Do you agree with me?
Yes, sir.
So, if you disturb a system initially, uh, ultimately, this second terms phi 12 of t into Z2 of t and phi 22 of t into Z2 of t, they are going to become 0 at a faster rate. And you will receive the response only from phi 11 into Z1 of t and phi 21 into Z1 of t. Are you with me?
Yes, sir.
Now, Z1 of t and Z1 of t is going to have same value at a given instant of time. Are you with me?
Yes, sir.
If I give you t equal to 10 seconds, Z1 of t here, both the places is going to have same value. That value can be considered to be alpha. Are you with me?
Yes, sir.
And then u1 of t will be equal to 511 into alpha, u2 of t will be equal to 5221 into alpha. So you are going to have the deformed shape very close to the first mode shape at very last time. Do you agree with me? Because the second term is going to vanish. समझ में आ रहा है?
Yes, sir.
So therefore, अब जरा मुझे बताओ, if it would have been the n degree of freedom system, so how will you write u1 of t? जो मैं बोल रहा हूं मैं आपको प्रूव भी करके दिखाऊंगा. How will you write u1 of t? Tell me. It will be 511 into z1 of t plus 522 into, no, not 522, it is 512 into z2 of t. Are you with me? Plus 513 into z3 of t. Do you agree with me?
Yes, sir.
ऐसे कहां तक जाने वाला है ये? This will go up to 5 1n zn of t. Do you agree with me?
Yes, sir.
Now z1 of t से z2 of t फास्ट डीके होता है, z2 of t से z3 of t फास्ट डीके होता है, z3 of t से z4 of t फास्ट डीके होता है. Do you agree with me?
Yes, sir.
So that means u1 of t will be governed by first few modes. Possibly 98% of the response u1 of t will be captured in first three modes. Are you with me?
Yes, sir.
Because z4 of t will vanish to zero so fast that after some time that will be insignificant. Are you able to understand what I'm trying to say?
Yes, sir.
Similarly, u2 of t कैसे लिखेंगे हम? u2 of t को हम लिखेंगे 521 of z1 of t, 522 into z2 of t plus 532 into z3 of t, so on and so forth. वहां भी पहले दो तीन मोड के ही टर्म्स हम लेंगे, बाकी के सारे टर्म्स निग्लेक्ट कर सकते हैं because they are vanishing to zero at a faster rate. Are you with me?
Yes, sir.
So what is the understanding that we have derived from this? The understanding that we have derived from this is ultimately at very large instant of time, at large value of t, every system is going to vibrate in its first mode. Are you with me? First mode का
Ye-
मतलब क्या होता है? The first mass will have displacement proportional to 511 and second mass will have displacement proportional to 521 with same proportionality constant as earlier. Are you with me?
Yes, sir.
Now, whatever I have said, possible है कि ये आपको समझ में नहीं आया होगा because it is too mathematical in nature. So what we are going to do is we are now going to plot this u1 of t and u2 of t. Are you with me?
Yeah. Yes, sir.
So this MDOF problem, its solution we are going to plot now. So t के values लिखूंगा 0, then 0.01 और कहाँ तक प्लॉट करेंगे हम? We will plot it up to, let us say, 12 seconds. Are you with me?
Yes, sir.
ओके तो यहां तक प्लॉट करेंगे. यहाँ पे हम क्या प्लॉट करने वाले हैं? पहले z1 of t. We are going to plot z1 of t first. Then we are going to plot z2 of t. Happy? चलो, so z1 of t लिख लेते हैं. What is the value of z1 of t? Tell me. Can you take a snapshot of this and can you dictate these values to me? स्नैपशॉट लो इसका, होने के बाद बताना.
Uh,
ले लिया?
yes, sir. हाँ ले लिया. Yes.
Okay. So tell me what is z1 of t? Exponential minus क्या वैल्यू?
Minus 0.017 t
017 into t, yeah,
in bracket
in bracket
0.0909.
090909. Is that right?
Yeah, right.
This multiplied by
cos
cos of
cos of in bracket 1.824 t
824 into t.
into
Yep.
t
Plus
plus 0.000
0.000
823
823
into sine in
sine
bracket
1.824
824 into
into
t.
t. Right?
Yeah, right.
Then bracket complete. So ये हो गया. Now I'm going to copy this expression. I'm going to paste it here. And now just tell me the change. Instead of 0.017, what was there?
0
Second, Z2 of t.
0.199
199. Then instead of this point 0.09, वो क्या था वहाँ पे बताओ, minus 0.6 था.
minus 0.060
हाँ.
984
Yes. What was the value here? 6 point something.
6.321
6.321. So here also it becomes 6.321, right? And what is the value here? 0.00832 के जगह क्या थी value?
0.0019
Minus, right?
minus 0.0019.
19. Happy?
Yes, sir.
So Z1 of t मिल गया, Z2 of t मिल गया. Now can you tell me what will be U1 of t and U2 of t? चल, what is the value of U1 of t and U2 of t? वो वैल्यू लिखते हैं. This is equal to क्या था वो? 0.6 into Z1 of t. So 0.6 multiplied by Z1 of t plus 0.89443. Is that right? 0.89443. 443 है, 447 है.
Four,
मेरा ये हैंडराइटिंग मुझे ही समझ नहीं आ रहा. 0.89443. 0.89443 multiplied by Z2 of t. Are you with me? ये हो गया U1 of t. This is U1 of t. Agreed? हाँ, तो देखो
yes, sir.
हमारा इनिशियल कंडीशन क्या था? इनिशियली द सिस्टम स्टार्टेड फ्रॉम U1 of 0 equal to 0. Do you remember that? We have given disturbance only to M2. U1 of 0 is 0. Happy?
Yes, sir.
हाँ, so आया कि नहीं? यहाँ पे आ गया. देखो 5.97 into exponential 10 power minus 7. So it is very close to 0. Happy?
Yes, sir.
Now let us start. Let us write down U2 of t. So what is U2 of t? U2 of t, how much should we get? U2 of t, we should get it as plus 100 mm. Are you with me?
Yes, sir.
So let us write down 0.8 into Z1 of t. 0.8 into Z1 of t plus क्या लिखूं? Minus 0.44721 minus 0.44721 into Z2 of t. So it has turned out to be 0.1 meter. Are you with me?
Yes, sir.
So is it correct? Yes, it is correct. Now we are going to plot both this. ये दोनों हम plot करेंगे. Now let me ask you a simple question. If before we plot this, if I ask you draw the displaced shape of the system at time t equal to, if I ask you to draw the displaced shape shape at t equal to 0.05 seconds. Are you with me?
Yes, sir.
हाँ, तो ये शेप हम कैसे ड्रॉ करेंगे जरा देखो. We are going to draw it. This the original structure. I am going to show it in black line. Happy?
Yes,
This
sir.
is the original location of M1. This is the original location of M2. Happy?
Yes, sir.
Great. Now, we are going to look at time 0.05 seconds. So this is the time that we are looking at. Happy?
Yes, sir.
U1 of t is positive, that is 0.0024, and U2 of t is also positive, 0.09835. तो दोनों M1 और M2 दोनों राइट हैंड साइड में मूव हुए हैं. Do you agree with me?
Yes, sir.
लेकिन व्हाट इज द रेशियो? लेट अस टेक द रेशियो दिस डिवाइडेड बाय दिस. तो कितने रेशियो से मूव हुए? सो अप्रोक्सीमेटली 40 टाइम्स रेशियो से मूव हुए. दैट मींस इफ u1 of t has moved by 1 mm, u2 of t would have moved by 40 mm almost. Do you agree with me?
Yes, sir.
तो ये यहाँ पे मैं ड्रॉ करने वाला हूँ. सो दिस m1 moves towards displaced shape. I am going to show it in this fashion. It displaces by this much amount. So m2 of t would have displaced by this much amount. Are you with me?
Yes, sir.
So m1 of t की displacement कितनी है? It is very small. How much is that? That is 0.0024. 0.0024. Whereas m2 of t की displacement 40 times है, and that is equal to 0.09 meter. 0.98 meter. Are you with me?
Yes, sir.
Are you able to understand this?
Yeah, yes, sir.
Okay. Now, let me draw the deformed shape at time instant 0.9. Are you with me?
Yes, sir.
तो यही बेस डायग्राम है. This was drawn at time instant t equal to 0.05. Now I am going to draw the deformed shape at time instant t equal to 0.9 seconds. Are you with me?
Yes, sir.
And we get interesting results. देखो, what is the displacement of you? What is the displacement of first mass? It has displaced towards left by 0.04, whereas the second mass has displaced towards right by 0.01. Do you agree with me?
Yes, sir.
So ये ratio क्या है? Almost 4 times. First mass has displaced towards left by 4 times than by the amount by which the second mass has displaced towards right. ठीक है?
Yes, sir.
तो displaced shape यहाँ पे red color में दिखा. This mass has displaced towards left by amount 0.04 approximately. However, the second mass has displaced towards right. Second mass तो right में चला गया, लेकिन by very small amount, that is 0.01. Are you with me?
Yes, sir.
Doesn't this surprise you? एक मास लेफ्ट हैंड साइड में जा रहा है और दूसरा मास राइट हैंड साइड में कैसे चला गया? So you can understand that mass m1 and m2, they are oscillating with different frequencies. Are you with me?
Yes, sir.
So let me start my video. Let me know if I am visible. Am I visible?
Yeah, yeah, sir.
This is mass m1. This is mass m2. Are you with me?
Yes, sir.
If they are moving in with the same frequency, or they are moving in sync, in synchronization, it is something like this. Happy? This
Yeah.
mass may move with more amount, but they are completing one oscillation in same time. So there will, if this mass is moving towards right, this mass would also have moved towards right. Are you with me?
Yes, sir.
This is called as in sync motion. But now I don't know how much I will be able to do it. This mass is oscillating at a smaller frequency, and this mass is oscillating at higher. No, I can't do it. If this mass is oscillating at smaller frequency and this is oscillating at faster frequency, so it may so happen that when this mass was on left hand side of mean position, this would have on the right hand side because of difference in the frequency, or because of phase difference, or because of non in sync vibrations of both the masses. Are you with me?
Yes, sir.
Okay, let us go back here. So that is the thing that I wanted you to understand. Now, what I am going to do is I am going to calculate the ratio of u2 of t by u1 of t. u2 of t by u1 of t का रेशियो यहाँ पे मैं कैलकुलेट करने वाला हूँ. Are you with me?
Yes, sir.
ये रेशियो क्या होगा? So this is 0.1 divided by this. Are you with me?
Yes, sir.
ये रेशियो बदलते जा रहा है, बदलते जा रहा है, बदलते जा रहा है. समझ में आ रहा है?
Yes, sir.
ओके. After some time, it's after 14 seconds, do you observe that this ratio is becoming constant somewhere close to 1.2? Are you able to observe that?
Yes, sir.
Let me take these things down. Let me go up to 20 or 25 seconds. You will see that observation clearly as I go to higher time. So this ratio has settled to 1.33. Do you agree with me?
Yes, sir.
कहा किसके बाद सेटल हुआ है? So after time equal to 18 seconds. Do you correlate something 18 seconds, 17 second के बाद ये होना चालू होगा? If I am correct. ऐसे क्यों हुआ है? जरा ये डीके देखो. Z2 of t has decayed down to almost zero at 17. If I stretch this graph further, देखो, if I stretch this graph further, are you with me? So at somewhere close to, we can say somewhere here, at after 35 seconds, it has almost gone to zero. Do you agree with me? Z2 of
Yes,
t. तो अब जरा ये रिस्पॉन्स देखो. ये रिस्पॉन्स इस तरीके का है. Z2 of t, if it is vanishing to zero after 35 seconds, the second term is not going to prevail. Second term is not going to prevail. That means the ratio of u2 of t upon u1 of t will be z 521 z1 of t by 511 z1 of t. Z1 of t will get cancelled out, and you will get the constant ratio 521 upon 511. So what is the ratio of 0.8 upon 0.6? Tell me. 0.8 upon 0.8 upon 0.6. It turns out to be
1.33.
1.33. So that's what you are getting. So after 35 seconds, so we should look at that ratio would have stabilized to, after 35 seconds, it has stabilized to 1.33. Are you with me?
Yes, sir.
So what happens majestically after some time, the second mode stops participating. That's what I was telling. After certain time, the second mode no longer participates in the response of the structure for both u1 of t and u2 of t. Do you agree with me?
Yes, sir.
And the response merely depends upon 511 and 521 and z1 of t. Are you with me?
Yes, sir.
And now, for any given, so after 35 seconds, for any given time, z1 of t and z2 of t will be constant. Do you agree with me? So let us take a time after 35 seconds. So let me take this 35.61. Hereafter, for a given value of z, for a given value of t, 35.61, this is u1 of t and this is u2 of t. Do you agree with me? And उनका ratio कितना है? 1.333. And what is the ratio of for these two elements of phi matrix? It is also 1.3333. That means its deformed shape will be something similar to alpha times phi 11 and phi 21. Do you agree with me?
Yes, sir.
So after some time, the deformed shape is multiple of first eigenvector, and therefore we call that as mode shape, first mode shape. Are you with me?
Yes, sir.
And what will be the frequency at which this mode shape will be oscillating about its mean position? The frequency will depend upon the frequency of Z1 of t. But what is the frequency of Z1 of t? Frequency of Z1 of t is omega 1. Are you with me?
Yes, sir.
So अब जरा देखो, if I were to plot the response, if I were to plot the response u1 of t after 35 seconds, 35 सेकेंड्स के बाद अगर मैं ये रिस्पॉन्स प्लॉट करता हूँ u1 ऑफ t और u2 ऑफ t, दोनों दोनों प्लॉट करूँ. लेट मी प्लॉट बोथ फॉर यू. सो लेट मी प्लॉट u1 ऑफ t 65 सेकेंड, 35 के बाद कुछ भी ले सकता हूँ, सो 65 से ले लिया. आर यू विथ मी?
Yes, sir.
Just give me a second. Now we are going to make the most important conclusion from this. So carefully observe what I am doing. I am plotting a response of u1 of t. Just a second. ओ उल्टा करना है इसको. Okay. Let us do it other way. Let me plot this, and then, by the way, this is the response of first mass, exponentially decaying. Are you with me?
Yes, sir.
Now let me edit this series, or let us not do that as well. Let it be like this. And now let me plot on the same series. Select data, add. So going to plot t here, and I'm going to plot z. Z1 of t, Z2 of t, U1 of t, U2 of this here. What has happened? Data series 2, edit. No. Anyway, will take some time, but we will plot it. 1 minute. Just go to 35. Then from here, I will take data up to 43 here. So spatial values. So I have reproduced that data, and in that this is time. So I'm interested in time, and I'm interested in only Z1 of t and Z2 of t. So this is deleted. U1 of t and U2 of t. This is ratio, so this needs to be deleted. U1 of t and U2 of t. This is Z1 of 2 and Z2 of t that I have deleted. Now let us plot this. Are you with me?
Yes, sir.
And unfortunately, only 2 oscillations we could capture. It's okay. On the same thing, let us plot, select data, add this, and this. What do you observe? What is your observation?
Sir, oscillation occurred in different
The
division.
oscillation does occur in sync. Do you agree with me?
Yeah.
Why should it occur in sync? Because after 35 seconds, Z2 of t starts playing no role. So the frequency of oscillation is only dependent on Z1 of t and Z2 of t. Z1 of t only for both U1 of t as well as U2 of t. Therefore, the masses start oscillating in sync. Do you agree with me?
Yes, sir.
So in sync का मतलब क्या है? Their frequency of oscillation becomes same. Do you agree with me?
Yes, sir.
Let us check what is the frequency of oscillation. So this is value 0.1247. Let us try to understand when do I get this 0.1247 back first time. So when do I get it back once again? Somewhere here. Let me check. No, it is minus 0.01247. So when do I get this back? It should go to 0. It should go to 0 and it should come back. So नेगेटिव से पॉजिटिव होना चाहिए एंड फिर से नेगेटिव होना चाहिए. सो फिर से नेगेटिव होके 0.012 आना चाहिए. हाँ, यस. Here, are you with me?
Yes, sir.
So what is the frequency? What is the time? 39.01 seconds. और ये टाइम कितना था? 35.55. So what is the time for one oscillation? 39.02 minus 35.55. And what is the inverse of this? 0.288. Are you with me?
Yes, sir.
Is that right? कुछ तो गड़बड़ कर रहे हैं हम लोग. Let us look at what is the frequency of Z1 of t. Z1 of t oscillates at omega d. Omega d1. So what is omega d1? It is 1.824 radians per second. Are you with me?
Yes, sir.
That is okay, but that has 824 and 1.824. Okay, this is frequency in hertz. So this is the frequency in hertz. So 2 pi f is equal to omega. I'm right. So I did not multiply it by 2 pi. Are you with me?
Yes, sir.
So 2 pi into this. So we have got it as 1.81, which is the damped natural frequency for Z1. Do you agree with me?
Yes, sir.
So इसका मतलब क्या है? After certain time, Z2 has stopped contributing. Only Z1 is contributing for U1 of t as well as U2 of t, and both the masses are oscillating with same frequency in sync. And what is that frequency? That is the frequency of first motion. Do you agree with me?
Yes, sir.
So how do we define now mode shape? तो मोड शेप को हम कैसे डिफाइन करेंगे? ये एक बार यहाँ पे डिफाइन करते हैं. So let us try to define what do we mean by mode shape. So mode shape is that shape the structure acquires such that all points on the structure, all points on the structure can oscillate at same corresponding natural frequency. Are you with me?
Yes, sir.
So what is mode shape? Mode shape is that shape of the structure, that shape the structure acquires. मतलब उसके सारे multiples. You multiply it by alpha, it's all right. That shape such that all points on the structure can oscillate at the same corresponding natural frequency. Are you with me?
Yes, sir.
Now what is the second mode shape then? तो जरा second mode shape अगर हमें देखना है तो second mode shape means we will have to look at this one 512 and 522. So 512, 511 and 512 and 522 are this. That means if the first mass goes towards right by 0.89443, the second mass will go towards left by 0.443. So हम इसको क्या करते हैं, इसमें से किसी एक को 1 बोलते हैं. So let me call 0.89443 as 1. Then what will be 0.44721? It will be 0.89443 0.44721 divided by 0.89443. So can you do that calculation and tell me the value? 0.44721 divided by 0.89443. So that turns out to be 0.5. So that turns out to be minus zero point 0.5. So that means if the first mass goes by 1 unit towards right, the second mass will go by minus zero point 0.5 towards left. Are you with me? This is the second mode shape. Are you with me?
Yes, sir.
What is the first mode shape? First mode shape. तो इसमें हम इसको 1 बोलेंगे. तो what will be the value of the second one? 0.8 divided by 0.6. So इसमें ये हो जाएगा 1.33. Are you with me? So if the first mass moves towards right by 1, the second mass will move towards right by 1.333 units. कोई भी इसका मल्टीपल ले सकते हैं. That is the first mode shape. How do we plot these mode shapes? So how does the first mode shape look like? वो मैं यहाँ पे plot करके दिखाता हूँ. This is M1. This is M2. Are you with me?
Yes, sir.
If this system has to vibrate in the first mode shape, तो पहला first mode shape कैसे दिखेगा? वो यहाँ पे draw करने की कोशिश करते हैं हम. So what is the first mode shape? In first mode shape, the mass goes towards right by 1 unit, first mass, and second mass will go towards right itself by 1.33. So if this is the first mass, this is 1 unit. Are you with me? Then the second mass must move by 1.33 units towards right. So second mass must occupy this position. Are you with me?
Yes, sir.
So if the structure vibrates in first mode shape, then what happens? the first spring is also stretched and second spring is also stretched. Do you agree with me?
Yes, sir.
Now similarly damping के बारे में अभी कुछ नहीं बोलेंगे. Now let us draw this is the first mode shape. First shape. Let us draw the second mode shape now. How do we draw second mode shape? So second mode shape में क्या हो रहा है बोलो. The first mass move towards right by 1. हाँ, तो ये तो डायग्राम ऐसे ही रहेगा. It has moved towards right by 1. Happy?
Yes, sir.
So this spring has stretched, no doubt about it. What happens to the second spring? Now second mass comes closer by 0.5. So this mass, instead of going towards right, it moves towards left by 0.5 amount. This is 0.5. Are you with me?
Yes, sir.
This is M1, this is M2, and this spring gets compressed. This is the second mode shape. So first mode shape is in sync motion. Happy?
Yes, sir.
Second mode shape is out of sync motion. Are you with me?
Yes, sir.
Okay. So this was all about the analysis of multi-degree of freedom system. Now the question that we are going to answer now is, how do I measure damping, or how do I ascertain that this damping is mass proportional or stiffness proportional damping? Because if it is not so, then we cannot use the same matrix, same transformation matrix phi to diagonalize C matrix. Are you with me?
Yes, sir.
तो ये अब करने की हम कोशिश करेंगे, but that we will do in the next class. Have you understood this problem? कैसे करना है?
Yes, sir.
Okay. So now what I'm going to do now is I'm going to summarize the solution steps for multi-degree of freedom system, and we are going to make some final remarks so that those remarks should be embedded in your mind forever. ये कभी भी भूलना नहीं है. ऐसे remarks हम करते हैं. Are you with me?
Yes, sir.
And then we are going to stop for today. So let us make. चलो. So if you have NDOF system, मतलब n degree of freedom system, NDOF system. What is the first step that you are going to do? The first step that you are going to do is you are going to write down or derive the equation of motion. Are you with me? How do you derive the equation of motion? You derive the equation of motion based on application of Newton's second law to all the degrees of freedom. जितने masses है उन सब masses को आप Newton's second law लगाओगे and you are going to derive the equation. Do you agree with me?
Yes, sir.
Okay. Now, so that equation will be of this form. Mass matrix. What will be the size of mass matrix? It will be n cross n, and it will be already diagonal. Do you agree with me?
Yes, sir.
M U double dot. What is the size of U double dot matrix? U double dot matrix will be n cross 1 plus C U dot. What is the size of C matrix? Damping matrix. It is
And
n cross
cross
n. What is the size of U dot? It is n cross 1.
and cross
We
1.
say that in general C is equal to alpha times m plus beta times k. If beta is 0, it is mass proportional damping. If alpha is 0, it is stiffness proportional damping. If alpha and beta both are non-zero, it is mass and stiffness proportional damping. Are you with me?
Yes, sir.
Plus k u. What is the size of K matrix? N cross 1. N cross n. What is the size of U matrix? N cross 1. This must be equal to F of T, which is a force matrix, which is also N cross 1. So in the next class, naturally, we are going to look at forced vibration problems. Are you with me? And here, The resonance has a different connotation. Resonance will occur either when the forcing frequency becomes equal to omega 1 or omega 2 or omega n. So यहाँ पे n number of frequencies will correspond to resonance. Are you with me?
Yes, sir.
Okay. So this is the governing differential equation. This equation is not complete. This is n governing differential equations which are coupled. These are coupled equations. Do you agree with me?
Yes, sir.
कितने डिफरेंशियल इक्वेशन्स है? n number of differential equations which are coupled. म्हणजे एका दुसऱ्याच्या पायात पाय. So we cannot solve this equation. So therefore we have to decouple this equation. How do we go about decoupling this equation? Before that, is this equation complete? No. You have u0, u of 0 as u0. This is the set of boundary initial conditions that you need to have. This is n cross 1. This is also n cross 1. Are you with me?
Yes, sir.
Then u dot of 0. This is also n cross 1. This must be equal to u0 dot. This is a matrix of initial boundary conditions, initial conditions. How many initial conditions do you have? N plus n. So 2n initial conditions. Do you require 2n initial conditions? Yes, because each of these n equations are second degree equations. So for each equation, you will require two boundary initial conditions. Are you with me? So how many initial conditions? 2n initial conditions are required. Are you with me?
Yes, sir.
कंडीशंस. अगर अभी कुछ समझ में नहीं आया तो ये वीडियो एक बार फिर से सुनना. In the context of previous video you will understand. Are you with me? Now, so this is the entire definition of problem. ये problem define हो गया. What is the step 2? What do we do? Yeah, we propose, we calculate m inverse k. Do you agree with me? And इसके हम आइगेन वैल्यूज एंड आइगेन वेक्टर्स कैलकुलेट करते हैं. आइगेन वैल्यूज एंड आइगेन वेक्टर्स कैलकुलेट करते हैं. डू यू एग्री विद मी?
Yes, sir.
How many eigen values you are going to have? N eigen values. How many eigen vectors you are going to have? N eigen vectors. What is the size of each eigen vector? It is n cross 1. Are you with me?
Yes, sir.
Then जो eigen values मिलते हैं उनको हम lambda 1 to lambda n arrange करते हैं such that lambda 1 is less than lambda 2 is less than lambda 3 less than lambda n. So we have n eigen values. Are you with me?
Yes, sir.
इसके करस्पॉन्डिंग जो आइगेन वेक्टर है उसको हम बोलेंगे v1 टू vn. सो ये v1 टू vn आइगेन वेक्टर्स को जैसे ही हम अरेंज करते हैं ये जो मैट्रिक्स मिलता है, ईच ऑफ दिस आइगेन वेक्टर इज ऑफ साइज n क्रॉस 1. So this total matrix is of size n cross n. This matrix itself is phi. Are you with me?
Yes, sir.
What is the crux? जो भी आइगेन वैल्यूज आए उसको ऐसे के वैसे मत लो, उसको पहले अरेंज करो इन असेंडिंग ऑर्डर. lambda 1 should be less than lambda 2 should be less than lambda 3 up to lambda n. करस्पॉन्डिंग आइगेन वेक्टर्स को एक के सामने एक रखो. जो मैट्रिक्स मिलता है that matrix is phi matrix. It will be of size n cross n. Do you agree with me?
Yes, sir.
Now we already know that phi transpose m phi then is diagonal. And phi transpose k phi is also diagonal. ये मैंने प्रूव करके दिखाया. Are you with me?
Yes, sir.
डायगोनल मैट्रिक्स को इस तरीके से दिखाने की भी मेथड है. Are you with me?
Yes, sir.
ये जो phi transpose m phi है, m was already diagonal, but phi transpose m phi is also diagonal. This matrix we call it as generalized mass matrix by capital M. This is small k. This matrix we call it as generalized stiffness matrix. Are you with me?
Yes, sir.
And we know that as C is equal to alpha m plus beta k. Therefore, phi transpose C phi will be equal to phi transpose m phi into alpha plus beta into phi transpose k phi. This matrix also will be diagonal because it is summation of two diagonal matrices. Agreed?
Yes, sir.
So therefore, phi transpose C phi is also diagonal, and this matrix we denote it by capital C, which is generalized damping matrix. Happy?
Yes, sir.
Now, so ये सब हमने कर लिया. We found out phi transformation matrix. What is the next thing that we do? We make a substitution. What is the substitution that we make? U is equal to phi z is the substitution that we make, where z is the matrix of generalized displacements, z2 up to zn. Are you with me? तो
Yes, sir.
U का size है n cross 1, size of z is n cross 1, size of phi is n cross n. Happy?
Yes, sir.
Then now, what do? We express z as phi inverse of u. Happy?
Yes, sir.
We use this matrix and we get the matrix of z zeros. Z0 will be equal to phi inverse of u0. Z0 is n cross 1 matrix. U0 is also n cross 1 matrix. Similarly, we get Z0 dot. These are the initial conditions. N cross 1 is equal to phi inverse of U0 dot. This is also n cross 1. So knowing U0 and U0 dot, you can get Z0 and Z0 dot from these equations. Do you agree with me?
Yes, sir.
Okay, then what do? We make this substitution in the governing differential equation. What do we get? We get m phi z double dot plus bolo
Uh,
c
C.
phi z dot plus k phi z is equal to small f of t. This is the force in parent coordinate system. So to have uniformity, everything हमें किसमें लेके आना है? Transform coordinate system में. So what do? We pre-multiply this both the terms by phi transpose. So phi transpose m pi z double dot plus phi transpose c phi z dot plus phi transpose k phi z is equal to phi transpose f of t. Are you with me?
Yes, sir.
हाँ, तो ये जो मैट्रिक्स मिल जाता है दैट इज जनरलाइज मास मैट्रिक्स एम जेड डबल डॉट प्लस दिस इज जनरलाइज डैम्पिंग मैट्रिक्स सी जेड डॉट प्लस दिस इज जनरलाइज stiffness matrix kz is equal to this is generalized force matrix f of t. Are you with me?
Yes, sir.
Subject to boundary conditions z1 0, sorry, z1 of 0 is equal to z1 0. This is n cross 1. This is also n cross 1, which we have already obtained. Z1 0, Z0, I'm sorry. Sorry. Z of 0, this is n cross 1 is equal to Z0. This is also n cross 1 matrix. This we have already obtained here. Similarly, Z dot of 0 is n Am I audible?
Yeah. Audible.
Shubham, am I audible?
Yes, sir. Audible.
Shubham, can you unmute and let me know if I'm audible?
Yes, sir.
Soham
Audible.
Joshi.
Yes, sir, audible.
Soham. Okay. So this is that. So these are the two boundary matrix. This is now we have got. And how do we write down u of t then? U of t, which is a n cross 1 matrix. This is obtained by phi set of t, which is n cross 1 matrix. This is the entire procedure of analysis of multi-degree of freedom system. Soham, are you with me?
Yes, sir.
Hopefully, I did convey my message, convey my point here. So we are going to start, or you can exit the class.